Hello friends, in this one I'm going to show you how to solve a small mathematical puzzle. Imagine I have two sets, A is a set and B is a set, and they're open. That means that the boundary basically is excluded. And I have a segment, and say this here, this boundary is at x equals 2 and this one is at x equals 3. What I want to do is set up a function that will measure the length of this segment from this endpoint, so that's not x equals 2 exactly, and to that endpoint, which is not exactly x equals 3, but in such a way that as that segment shrinks, it never actually leaves the circles. That's the goal here. So you may want to pause the video and think about it, but I'm going to do it this way. I'm going to set up a function that says x equals 2 minus 1 over n. And on this side, I'm going to create a function that looks like this. X equals 3 plus 1 over n. Now, why would I do that? Take a look at these tables. So here, I have 2 minus 1 over n. There's an error above it because the program that I use basically allows you to iterate through the values of n. So you can see 2 minus 1 over n change in the value. So for example, when n has the value 1, here you would have 2 minus 1 over 1, which is 2 minus 1, which is 1. Okay, basically. And then that would be like the position at this point right here, okay? So that would be this endpoint, but its value would be 1 relative to the origin, which is not shown here. I want to be clear on what that is, okay? It's not the length of the segment just yet. Be careful with that. For example, if n has this value, over here, for example, okay? When n has the value 10, then this would be 2 minus 1 over 10, which would be 1.9. So that would be very close to x equals 2. Again, these distances in this column are the ones measured to say the center or the origin, which could be all the way somewhere over here, which is not shown. But when you are at 1.9, you see that's very close to the x equals 2 portion, but you can't ever actually escape from the circle, can you? Because even if n had the value 1 billion, this would be 2 minus 1 over 1 billion, which is still not quite 2. So you can't ever actually escape from the circle. Look at this side, okay? Look here. This is what is also interesting. So, for 3 plus 1 over n, when n has the value 1, you would have 3 plus 1 over 1, which is 4. And that would be that first value over here. When n has the value 10, for example, you'd have 3 plus 1 over 10, which would be 3.1. And that's this value over here. But again, even if n had the value 1 billion trillion, this would be 3 plus 1 over 1 billion trillion, which is still not really 3. Which means this segment end would get trapped ever and forever slightly to the right of the 3. It could never actually escape the circle. These are just line segments after all. So how can you set up, for example, a function that represents the distance between the two? Well, you could just take 3 plus 1 over n and subtract from it 2 minus 1 over n. And here actually all the distance would ever and only be positive. So I'm going to do it in absolute value, but for this particular case, you wouldn't even need the absolute value bars. So it would look like this. This is what you would have as a picture. You would have 3 plus 1 over n minus 2 times 1 over n. Then you can do 3 minus 2. So that's 1. And then you can do basically 1 over n minus a negative 1 over n, which would become 1 plus 2 over n. And if you graph that, well, the software that I use requires x as the variable, but it's really 1 plus 2 over n. That's what it's supposed to be. If you graph this 1 plus 2 over n, it would look like this. So here n is increasing forever. And then you can see this settles down to a value of 1, but it could never actually reach a value of 1. Right? Because it's 1 plus 2 over n, and this function which represents the distance. Again, here I don't even need the absolute value bars, to be honest. But I kind of kept it out of habit because I was thinking about distance. So the point is that as n goes towards positive infinity, the limit of 1 plus 2 over n would actually be 1, but you can't actually ever reach it. And that's like saying that this segment essentially right here would get forever trapped. In other words, it would always have a little bit of a value slightly to the left of the 2 and slightly to the right of the 3 and never leave the circles. I thought this was a kind of interesting mathematical mystery, actually. Anyway, that's it for me. Thank you so much for watching. Please leave a like and subscribe. I'll see you in another video.